So my name's KaLiyah.
I'm Luna.
I'm Noel.
Today we're going to talk about carbon capture and sequestration.
So the topics we'll be covering today are how carbon sequestration works and what exactly it is. We'll also cover its benefits and limitations and talk about its impact on our society as a whole. All right, so there are two types of carbon sequestration, but what carbon sequestration does is separate and capture carbon dioxide so that it doesn't enter our atmosphere. And in that way, it is carbon negative, so it's not actually adding into our atmosphere. The first way of carbon sequestration is biological, which is the removal of CO2 through the growth of plants and microorganisms. The Yale School of Environmental Science found that there was more carbon in our soil than in the atmosphere and in all plant life combined. So the whole idea behind carbon sequestration biologically is to put the carbon back where it came from and use it as a renewable resource. And the way that we can do this is through farming techniques like conservation tillage, which is where we don't manipulate the soil to promote growth. Afforestation, which is planting new forests, and also cover cropping, which is when farmers cover their soil in between crop rotations with small grains like clover in order to promote organic matter and growth in their soil. There's also a form of carbon sequestration called geological capture, which stores CO2 underground. This is usually in like man-made cavities, but it can be in pore spaces between the rocks as well. And the way that we can do geological sequestration is through enhanced oil recovery, which is where we inject carbon in oil mines so that we can push out more oil up to the surface. So it has a good economic benefit there. We can also dissolve the carbon in water or oil underground, and we can also attach it to mineral precipitates deep underground to keep our carbon below the surface of the earth. So like I was talking about earlier with the biological capture, it can happen naturally, like when it is captured through trees, or some of it is also dissolved in the ocean, which we can't really control. But a lot of it also has to do with the way that we farm. So changing our farming methods to more organic ways will help keep our carbon in the soil. We plant new trees in afforestation. And there's also programs started by the government, like the US Conservation Reserve Program, which pays farmers to reduce the carbon impact of their farming methods. And geological has several different trapping methods, including buoyant trapping and residual trapping, which use surface tension and pore seals to keep the carbon below the earth. There's also enhanced oil recovery, which can be done to get every last drop of oil out of the ground. But for the most part, the geological capture is still being developed in different technologies. And so I have a little image here of the ways that we can sequester carbon underground. Each of the little lines going down into the ground are showing pipelines of CO2, whether it be offshore, like on the right side of the image, or if it's at a plant, like on the left side.
So now we're going to go over the sequestration process. So first, carbon dioxide is separated from the organic material during combustion in power plants and other places in which carbon dioxide is usually a waste product. And it is captured, compressed, and then transported, usually through a pipeline to injection wells where they are then stored deep underground or under the ocean, where the carbon dioxide is permanently stored.
Now we're going to talk about the benefits and limitations of the key methods of carbon sequestration. So starting with biological, some benefits is that it mitigates climate change because it takes the CO2 from out of the air. It reduces runoff and erosion because because it'll have better soil, and so they'll be able to reduce the amount of runoff that it's transported to the ocean. It also absorbs carbon dioxide from the atmosphere. This is a part of trees' natural process, which is photosynthesis. And then it also has the benefit of biomass gasification, where the biomass from the trees and the soil and the crops are basically converted into combustible gas, which can be used for a number of things. However, it does have some limitations, which includes the decades it takes to mature. As we know, trees take thousands of years to grow and become big and tall as what we see today, but it can also lead to a lack of biodiversity, and sometimes it can negatively affect the nutrients that are in the soil. And another big caveat is that it requires a lot of land availability. So in the city, it's very limited places to plant trees because it's a lot of buildings and cars. And so that can be a problem. As for geological carbon sequestration, some of the benefits is that it mitigates climate change because it takes the CO2 from out of the atmosphere. It also has economic growth because the oil that's captured can be used or sold for like monetary value. And also the carbon can be used to generate power. However, it does have limitations, which can include a leakage or environmental damage. So with the carbon being stored in a location, if something goes wrong and it leaks, all of the CO2 is released back into the air. It's also very expensive to sequester carbon, especially in the geological way. And then it is less effective than renewables because, as I stated before, when you sequester the carbon and a leak happens, all of the CO2 is released back into the air. However, with renewables, there is no release of CO2 because it is using different form of energy. And there's also limited storage to hold the carbon.
So now we're going to go over the impact of carbon sequestration. There's obviously huge environmental benefits to this. So right now, over 80% of the world's energy comes from fossil fuels. So when we are able to capture the carbon and sequester it underground, we're actually reduce able to greatly reduce carbon emissions and allow for low carbon electricity generation, as previously mentioned. And to provide some imagery for this, the projected reduction of greenhouse gases from carbon sequestration would be equivalent to the amount done by 62 million trees over a decade. However, that doesn't mean it doesn't come without risk. And one of those risks is ocean acidification. So if you store it below ocean water, since carbon dioxide can reduce the pH of the ocean water, it could terribly affect the ecosystem around wherever the injection point was. And then also, as previously mentioned, you could get leaks. And if the carbon dioxide leaks into the ocean, it could further damage that marine biolife. There's also an adverse effect it could have on plants as well, because it could decrease their efficiency as well as increase their water intake, which would become a huge problem for plants with that are used to water scarcity. And there are a variety of obstacles that can get in the way of its implementation as well, such as the lack of restrictions and taxes and other things that create some sort of gray area around the subject of carbon sequestration. There's also very expensive, not only to actually get the materials to do this, but also to pay and incentivize the workers who would be responsible for these things. For it would cost like $30 to $90 per ton of carbon sequestered, and you're talking about around 500 million tons of carbon that would need to be sequestered. So probably around like 15 billion at the least. And then the final problem would be liability, because somebody would have to be held responsible for whatever happens to the ocean, whether it's leaks or workers get injured in the process.
And as for a summary, carbon sequestration is a carbon negative technology. There are two main kinds, which is biological and geological. Each of these has their own benefits and limitations. However, they both can reduce the amount of CO2 that's in the atmosphere. But there are some risks that come along with this method, such as ocean acidification and the effect that it has on plant soils. And there are a few obstacles that come with implementing this. And that concludes our presentation.
Thank you for listening.
Stop recording. Okay.